Hello everybody, this is Mr. Walters, AP Chemistry, KSP, Solubility Products. Would be a good idea to review the solubility rules and be ready to apply those. For right now, let's just take a look at a few chemical reactions. These would be precipitation reactions, double displacement reactions. And what we're going to do is just simply look for a precipitate. On the left, we have a solution of potassium iodide aqueous. So that's on the left. That would be right here. And what we're going to do is add lead nitrate solution to that. So here's my lead nitrate. And this is aqueous. Nitrate solutions are soluble. Floating around, let's see if I can show it to you. There's the solution. So we have the lead ions, lead double positive, are dissolved in solution. And the nitrates are dissolved as well. So let's see. So we do have a solution here. So we've got lead ions hydrated by water, nitrate ions hydrated by water. What would be the IMFs between the water and the lead double positive ions? Let's see, so that would be an ion dipole IMF. Nitrate is colorless solution. It's essential for the production of fertilizers and explosives. You should be able to write NO3 minus and do a Lewis structure for that. You should be able to do that. In fact, go ahead and do that. NO3 minus Lewis structure, do that right now. Of course, you can pause this at any time. If you're looking at that nitrate ion, the Lewis structure, you're going to see sp2 hybridization. Don't forget to bracket and put a negative charge outside of the bracket. Let's see, bond angle is going to be 120. This is soluble in water because of that negative charge, and water with its polar structure loves negatives, and it's going to hydrate and surround that in multiple concentric circles. Of course, the H's, the two H's on the water, on the boomerang water molecule, the two H's would be pointed towards the nitrate. Anyway, we've got our lead nitrate solution, and here is our potassium iodide solution. So there we go. We see a beautiful solid precipitate. Again, here's the reactants: aqueous lead 2 nitrate plus potassium iodide. You guys write the molecular equation of that and then write the net ionic equation. Now next, we've got another solution. This is, I believe, that one is sodium chloride, aqueous sodium chloride, ion dipole, IMFs. Let's add some silver nitrate to that. So this is silver nitrate. Notice the silver ions are dissolved in solution here. And notice the solid precipitate formed. Write the molecular equation and write the net ionic equation for this reaction. So here we go. This is silver chloride aqueous plus sodium chloride aqueous. You're going to get product. I want you to figure out the products. I want you to identify the precipitate, obviously. That's important. Notice we get gravity having its effect there. And yeah, so these are precipitation reactions. Let's take a look at another precipitation reaction. Let's go with sodium carbonate and calcium nitrate. So this is sodium carbonate and sodium carbonate and calcium nitrate. Okay, just adding a little bit more of the calcium nitrate. Now it's the sodium carbonate. So there's the sodium carbonate. And notice the precipitate. So again, sodium carbonate and calcium nitrate. Write the net ionic for that. Indicate spectator ions for each of these. Again, that is, we started off with calcium nitrate, and we've added sodium carbonate. Remember, all alkali metal salts are soluble, along with ammonium salts, they're always soluble. Now this is of particular interest. This precipitate here is interesting for a number of reasons. So this is calcium carbonate solid, calcium carbonate precipitate. And shellfish, mussels, clams, pearls made from shellfish. These are all calcium carbonate-like materials. In fact, the bluffs, which are spectacular in this area, hopefully we'll be able to get out and view these when the weather changes. Get some fresh air. I need some fresh air. Anyway, essentially the bluffs were produced by shelled organisms compacting over the course of exceedingly long periods of time. So calcium carbonate, stalactites, stalagmites, these rock features in caves. That's calcium carbonate, and the calcium carbonate is produced in a similar way through these sorts of chemical reactions. I guess we could take it a step farther, and we could talk about the eggs of birds are calcium carbonate. Now, bones are not calcium carbonate. They would be more similar to calcium phosphate-like materials. Not pure calcium phosphate solid, but calcium phosphate is a component of the minerals of bones. So again, these are produced by precipitation reactions. If the concentrations of certain materials in your body begin to exceed certain limits, we could get precipitation reactions occurring in the kidney, and that could lead to kidney stones. So these are important for a wide variety of medical and other sort of important applications. Well, let's see what we got here. Right here, this is copper 2 sulfate. Notice the color. So this is copper double positive. The hydrated copper ions are what gives this its unique color. The sulfates are going to be colorless. Let's add a solution here, and let's see if we get a precipitate. We do. So what was this reaction? This is aqueous copper sulfate plus aqueous barium chloride. Let's add a little bit more. So aqueous barium chloride. So the precipitate here, I'll give it away. The precipitate is barium sulfate. So if you were going to get an X-ray of your intestines, you might be required to drink some type of barium sulfate material, which would coat your intestines as it passed through the digestive tract, and then when you had an X-ray, the solid would diffract the X-rays, making the image of your intestines much more easy to see. So these are precipitation reactions, and this is our introduction to solubility products. Make sure you review the solubility rules. Make sure you can write the net ionic for any precipitation reaction. And we will be moving from this to KSP, which is simply following the equilibrium expression rules that we've already been talking about. Now, one thing I want to emphasize here. We've talked about these precipitates, these solid precipitates, as being insoluble. They actually, as I mentioned, are slightly soluble. So, in other words, we've got this solution here, and we have this precipitate here at the bottom. So this is lead iodide solid precipitate, lead 2 iodide. So you can see there's plenty of solid there. What you need to realize is that small amounts of the lead ion are in equilibrium and have actually dissolved and are spread out in that solution. So that solution has small amounts of Pb, lead double positive ions. There's also I- ions that are dissolved in this solution in small amounts, and it's an equilibrium situation. So we have equilibrium between the lead iodide solid and its component ions. When we write this equilibrium expression, we're going to call this the K, not Kc, that's important, not Ka or Kb, those are obviously important, not Kp, Kp would involve only gases. So this is KSP, SP for solubility product. Again, notice these, you see the solid here, this would be in equilibrium with small amounts of dissolved ions. Same way here, this would be in equilibrium with small amounts of dissolved ions. This, I believe, was the calcium carbonate, so obviously plenty of calcium carbonate solid, but floating around in here you would have small amounts of calcium double positive ions, aqueous, and carbonate ions floating around in here in small amounts, aqueous. All right, so let me go to the board so we can discuss this further.